Alright, in our last video we talked about what to do in the early part, like the planning stages of your report, to make it suitable for, or what is expected for, later years in high school. Now this is what we're going to try to do with the rest of it now. So let's have a look at what we need to do with our data. When we have tables of information, you should be having a complete table. Remember that we only see everything at the top tells me what's going on, and down here is just the values. Alright, raw data means the data you measure. So we should be seeing that somewhere. So I need to see your trial data. I need to see all of it, as does everyone. As soon as I do something with it, it becomes what we call process data. Now, I'm okay with that being in the one table if you have all of it there, but it must all be there. Make sure this stuff is there. That lets me know where these other numbers, this average number, comes from. Right, so you've got to be really, really careful to include everything. Now, look very carefully. I've got units all the way through this. I tell people what I'm measuring. It's all clear. Yours should be clear also, and that was covered in the early videos we did on this. Right, when we're doing this, set it up properly. The independent variable is here. Here is my dependent variable. Okay, just some basic stuff. Make sure the units are there, and make sure you label the trials. Now this tells me that all these trial 1, trial 2 and trial 3 are measuring plant height in centimetres. So make sure you're clear, it really is important. And of course only numbers at the bottom, and we've already been through that and we shouldn't have to go through it anymore. Alright, now we're looking at what we've done here, and this is I either call this a summary table or a process data table. In other words, I've taken my measurements and I've done something to them. In this case, I have done an average. Right? That is actually changing the numbers. Now, something important here, when you're processing data, if you're measuring data, we know that you measure to the number of decimal places on the equipment you measure, you're using. Alright, so if your equipment gives you 2 readings to 2 decimal places, you hold it to 2 decimal places. So your raw data would be decimal places. And this means that your process data should also be to the same number of places. Just a little thing, but important. Alright, now these sort of tables are very much in demand because they help you understand the big picture. Alright? When you are doing this, make sure that you have this nice and clear so that people can see the trends and patterns in data that are here. And it's easy to make a comparison. Like if we've got all these things here, I can now make a comparison between the 3 ml of water right through to the 7 ml of water. Make sure you tell me where the numbers come from. So if you do a calculation, you must, not should, but must, have a little section underneath your table saying sample calculations, and then do one example, only one, of each different type of calculation. So if you are doing, let's say, a average calculation, you show me one example of how you got that number. Now I can find the number you show me in your process data table, and then I understand what you did to get there. So you're showing me that. As I say all the way through here, things are important. Now you can read through these as you go through. It's about showing me what you did, where the numbers come from, right? And also being careful with decimal places. Now, if you really, really want to go into this, and I would be suggesting that in years 11, 12 and 13 you would be, Your teacher will talk about a thing called significant figures, which I'm not going to go through at the moment. And this is talking about how you record your data. So instead of talking about decimal places, you talk about significant figures. It's similar but not the same. Right, line graphs. In science we tend to do line graphs, and we tend to have our dependent variable up the side on your vertical axis and your independent variable on your horizontal axis. And our line is going through but does not have to touch the data points. You show all the data points and then put your line through. It is not a join the dots. Make sure you use a trend line. A trend line shows me the pattern. Now, when we're using these points, we are saying that they are as good as we can make them. Are they 100% accurate? No. More about that when you go to little things like accuracy and errors and things like that. Again, in 11s, 12s and 13s. You'll be doing lots more work on that in those sort of years. Now, but what effectively it means is the dot indicates approximately where the value is, or where we think the value is. And so all we're saying is that that line shows us that this pattern tells me that as this increases, dependent A increases, dependent variable B will increase also. Okay? So don't be too hard on yourself when you're doing it, but make sure you tell me what's going on. Now, make sure you put a title, not just A versus B. Give me a word, give me a sentence to say, oh, this is showing how amount of oxygen produced by a plant changes as the temperature changes, or something similar, something to tell me about what's actually going on. Now, underneath your graph, you should make a couple of sentences comment about it. You might say, as you can see, as the independent variable increases, the dependent variable increases too. So there is a definite relationship between the two. I would be expecting you to tell me what sort of relationship exists. So when you talk about this, you might include things like the slope or gradient to describe how quickly the change is happening. Now, sometimes you might actually get them changing a direct dependency or a direct relationship might exist. All right, if a direct relationship exists, in other words, if I increase it by 1, it increases by 1, that's fine. You tell me. But other than that, you might just say, as we can see, as I increase my independent variable, my dependent variable also increases. Or, as my independent variable increases, my dependent variable decreases. Or whatever you see happening. All right, so you should be able to tell me a little bit more about this and tell me I'm expecting more information about the actual line itself. So you might be telling me about the slope. You might be giving me some extra information to tell me what's actually going on between these two variables. Right, more about this in the next bit.